The open-source AI race is intensifying. Across Beijing, Shenzhen, and Guangzhou this week, China's tech giants, Tencent, Baidu, and Huawei, have launched powerful new open-source AI models, challenging the dominance of Western leaders like OpenAI and Google, and signaling a dramatic shift in global technological power. On July 3rd, Tencent unveiled its groundbreaking Hunuan A13B model. This is not just another large language model, it represents a leap in efficiency and accessibility. Despite its enormous total size of 80 billion parameters, Hunuan A13B uses only 13 billion during inference, thanks to its advanced mixture of experts architecture. This means it can run on a single mid-tier GPU, bringing frontier AI capabilities into the hands of smaller developers, startups, and researchers worldwide. Its architecture is designed with two modes of reasoning: a low-latency, fast mode for instant responses, and a slow mode for complex, multi-step reasoning, allowing deep analytical tasks without sacrificing efficiency. Even more impressive is its massive context window of 256,000 tokens, roughly equivalent to 1,500 pages of text, enabling it to process vast documents, research papers, and complex coding projects seamlessly. Benchmark results speak for themselves. Hunuan A13B has achieved leading scores on BFCL v3, T-Bench, C3 Bench, and Complex Func Bench, outperforming much larger models in logic, mathematics, programming, and agent tasks. Its tool use capabilities and long context performance even surpassed models several times its size. Meanwhile, Baidu has taken a different approach by revolutionizing search itself. The company has released an upgraded AI-powered search engine, shifting from keyword queries to natural language conversations. Users can now generate text, create images, and plan entire trips with conversational prompts. It supports longer, more complex queries, integrating voice and visual input for a seamless, multimodal experience. At the core of Baidu's new search platform are 4 AI agents working together to reason through intricate user requests, delivering highly contextualized and accurate results. Alongside this, Baidu open-sourced its massive Ernie 4.5 model. Building on previous versions, Ernie 4.5 focuses on what Baidu calls deep thinking, offering capabilities comparable to OpenAI's GPT 4.5 at significantly lower computational costs. Baidu's open-sourcing move further accelerates AI accessibility for developers worldwide. Additionally, Baidu introduced Muse Steamer, a business-focused AI video generation tool that transforms static images into short videos of up to 10 seconds, enabling rapid content creation for marketing and social media. Not to be outdone, Huawei has launched Pangu Models 5.5 through its Huawei Cloud division, focusing primarily on industrial AI rather than general-purpose chatbots. Pangu 5.5 incorporates a mixture of experts architecture with 256 experts, switching adaptively between fast and slow thinking modes depending on task complexity. This design boosts computational efficiency up to 8 times compared to previous models. Huawei's approach is geared towards specific industrial applications. For example, its AI models have been used to detect pipeline defects with sub-millimeter accuracy, improving identification efficiency by 40% and reducing manual workload by 25%. They also play a role in autonomous driving development, generating synthetic videos to train vehicle perception systems more efficiently. Importantly, Huawei has open-sourced its Pangu models, including the 7 billion parameter base model and the 72 billion parameter Pangu Pro MOE, along with inference technologies optimized for Huawei Ascend chips. This strategic move aims to expand the Ascend ecosystem and encourage collaborative research within the AI community. The global implications of these developments are profound. First, competition has intensified dramatically. Chinese companies are not merely catching up. They are producing competitive, innovative alternatives with open-source access, directly challenging Western tech leaders. Second, this open-sourcing trend is democratizing AI. By making these powerful models available to the public, barriers to entry are lowered for developers, researchers, and small enterprises, fostering global innovation at an accelerated pace. Third, the focus on computational and economic efficiency is reshaping AI deployment. Models like Tencent's Hunuan A13B can operate on mid-range GPUs rather than expensive clusters, expanding their accessibility beyond elite institutions to everyday developers and engineers worldwide. Fourth, the geopolitical dimension is significant. China's aggressive push for open-source AI aligns with its broader strategy of technological self-sufficiency. By building domestic AI ecosystems and offering models globally, China is laying the groundwork for parallel technological networks that may eventually reshape global supply chains and software dependencies. Fifth, Huawei's industrial AI focus reflects an emerging trend in AI development, the move towards highly specialized models that solve concrete, sector-specific problems, rather than merely building ever-larger general-purpose chatbots. This strategy accelerates automation, enhances productivity, and directly impacts real-world operations in manufacturing, agriculture, transportation, and scientific research. Another critical dimension of the open-source AI race is geopolitics. American sanctions on advanced semiconductor exports to China, especially high-performance chips like NVIDIA's A100 and H100, have placed significant constraints on Chinese AI development. These chips are essential for training and running large language models at scale due to their unparalleled computational power and energy efficiency. Faced with these restrictions, China has rapidly shifted its strategic focus towards domestic chip production and technological self-reliance. Leading the charge is Huawei with its Ascend series of AI chips. The Huawei Ascend 910B, for example, offers computational performance competitive with NVIDIA's A100, enabling Chinese tech companies to continue developing frontier AI models without depending entirely on imported hardware. In parallel, Alibaba's T-Head division is developing RISC-V-based AI accelerators tailored for inference tasks, aiming to reduce costs and build a fully Chinese-controlled AI stack. These efforts are not only technological but deeply geopolitical, ensuring China's AI industry remains resilient in the face of external pressure. This strategic pivot is reshaping China's semiconductor industry itself. Billions of dollars are being invested into advanced manufacturing, packaging technologies, and local GPU design startups. Companies like Beren Technology, More Threads, and Cambricon are emerging as national champions, focusing on developing AI-specific GPUs optimized for large-scale deep learning workloads. The results are already visible. Huawei's Pangu 5.5 models, for example, are fully optimized to run on Ascend chips, bypassing the need for NVIDIA hardware entirely. This vertical integration of AI models and domestic chips strengthens China's position, creating a parallel AI ecosystem decoupled from Western supply chains. Ultimately, American chip sanctions, while designed to slow China's technological rise, have triggered a massive wave of domestic innovation. China's AI companies are now pursuing a dual strategy, building cutting-edge open-source models to gain global influence while simultaneously investing in indigenous hardware to secure their independence. This combination of AI software leadership and chip self-sufficiency could fundamentally reshape the global technology landscape in the coming years. Finally, the collaborative innovation enabled by open-source AI models will likely catalyze rapid advancements. Researchers and developers worldwide can build upon these foundational models, customizing and refining them for unique local and industrial needs without starting from scratch. In short, the latest moves by Tencent, Baidu, and Huawei highlight a rapidly evolving global AI landscape. The rise of powerful Chinese open-source models is not just a technological milestone, it represents a tectonic shift in the balance of AI power. Western companies like OpenAI and Google now face direct competition not only in performance, but in accessibility and adaptability. The race is no longer about who can build the largest or most advanced model alone. It is about who can empower the world's developers, scientists, and industries most effectively. As the open-source AI revolution gains momentum, the future of artificial intelligence is set to become more diverse, more collaborative, and more decentralized. The question is no longer whether open-source AI will shape the coming decade, but rather who will lead this transformation and how it will redefine global technological power. For now, one thing is clear. The AI arms race has entered a new era, And in this era, open-source innovation may prove to be the most disruptive force of all.